Hello students, welcome to OrganiChemVerse YouTube channel. In this video, I am going to teach you how to find out chirality centers for the given molecule. Before we get started, let me explain what are chirality centers. Chirality centers are the carbons where they are attached to four different groups. What is it so special about this chiral centers or chiral carbons? When carbon is attached to four different groups, it becomes optically active. What is optical activity? So in isomerism, you might have studied that a molecule can rotate a plane of a plane polarized light, then we call it as optically active molecule. So that means what? When a carbon is attached to four different groups, it will have certain optical activity. It exhibits one more isomer molecule and we call it as enantiomer. So enantiomers are non-superimposable mirror images which can rotate the plane of a plane polarized light. Once you know about this chiral carbon, we can start analyzing this molecule and mark the chiral carbons. Students, remember a carbon must be attached to four different groups. That means a carbon-carbon double bond or carbon-oxygen carbon cannot have a chiral carbon. So we can ignore those carbons there. Let's start from this carbon. Since it's carbon-oxygen, so it will be planar. So it will not exhibit the chirality. So we can ignore this. Look at this carbon, it will be attached to two hydrogens. So this is also not chiral. Let's check this carbon. We have OH group attached and there is a hydrogen. So there are two different groups. There is a CH2 here and CH2 here. Many students assume that since there are two CH2 group, okay, this is not a chiral carbon, it's achiral. No, it's not like that. You have to move on to the next carbon to check if there is any difference. Ignore these two CH2, then move to the next. See, this carbon in turn attached to CO. And what about here? It is attached to a carbon hydrogen. That means, yes, there is a chiral carbon here. Therefore, we have recognized one chiral carbon here. Alright, moving on. We have done till here. So this is attached to two hydrogen, so ignore it. But let's move on to this carbon. It is attached to oxygen and again we have CH2 and CH2. Move on to the next one. We have CH but here we have CH2. Then there is a second chiral carbon. So mark this also. In the exam as well you can always mark it like this. So 1 and 2. CH2, CH2, not possible. Now look at this carbon. We have one hydrogen here. If there is no fourth bond, remember there will be hydrogen because these are bond line structures, isn't it? That's why. Now there is fourth hydrogen. So CH2, CCH3, CC. So obviously it is having four chiral carbon. Why obviously? Because by looking at the groups only you can make out, yeah, this carbon is somewhat different, right? So far how many we got? 1, 2 and 3. Now look at this, methyl is there, hydrogen is there. This is tertiary carbon and this is a double bond carbon. Obviously we have one more chiral carbon here. 1, 2, 3, 4. So far this side I have got 4 carbons. Alright. Moving on, double bond carbon I cannot take. Same here also I can't take. Then let's check this. A carbon here, carbon here, carbon here. Move on. Of course there is a double bond carbon here and we have CH2 and here we have CH. Therefore there is a fifth chiral carbon over here. Right. Now moving on to this. Oxygen is there, CH3 is there. Yeah. So obviously this also. So like this if you keep practicing, just by looking at the group you can easily make out. See here, two hydrogen, not possible. But look at this, methyl is there, double bond is there, then CH2 is there. Yes, this is our next chiral carbon. And moving on here, oxygen carbon we can totally ignore this and look at this carbon. It is attached to ethyl, methyl, CO, and the fourth bond is because of the hydrogen. Yes, there is a chiral carbon. So bigger the molecule, you have to be careful. You have to check from carbon to carbon. So here CH to CH3, not possible. You can ignore it. So this molecule is basically a lipid lowering drug called as lovastatin, and we are finding the total number of chiral carbons. So let's count 1, 2, 3, 4, 5, 6, 7, 8. Yeah, the final answer is 8. There are 8 chiral carbons in the given molecule. If the question is how many total isomers are possible for this, then you have to use the formula 2 to the power n, that means 2 to the power 8, right? But that's not the question. Here the question is you are supposed to calculate the chirality centers only. So there are 8 of them. Suppose if they ask you total number of optical isomers, only then you have to use this. So here the answer is there are 8 chiral carbons for the given molecule. Thank you for watching this video, and if you have any questions based on chirality, you can always post your questions in the comment section. Thank you.